So we've got the function cosine squared, and we need to describe it. So we need to find out minimums, maximums, where it's increasing, decreasing, concave up and concave down. So the first thing to do is take the derivative. So the derivative will be, first of all, it's going to be the power rule. So 2 times cosine of x. And then take the derivative of cosine, which is sine. And then set this equal to 0. And of course the number 2 is not equal to 0, but both sine and cosine do equal 0. So you can separate these and then say, when does cosine of x equal 0? And when does sine of x equal 0? So cosine would look like this from 0 to 2 pi, and it would equal 0 2 times, the first one being pi over 2 and the second one being 3 pi over 2. And then for sine, that would look like this, again from 0 to 2 pi, and then we've got 3 times at 0, at pi, and at 2 pi. So we actually have 5 critical values to consider. Then the next thing that I would do is use a calculator and go ahead and graph the function. So I graphed cosine squared, and there would be 1, 2, 3, 4, 5 minimums and maximums. So that corresponds to the 5 answers that we just got. So then I could find the actual points. So actually I could just look at this and see the biggest that cosine gets is 1. So that means the biggest cosine squared gets is 1. So this y value up here would be 1, this one would be 1, and this would be 1. And then this would be 0, and this one would be 0. So I put this off to the side, and so the maximum values, that would be, this one would be 0, 1. This one would be right in the middle, so the middle one is pi, so that would be pi, 1. And then this one would be the last one, which is 2 pi, so 2 pi, 1. And, excuse me, for the minimum values, that would be this one, and I'm pretty sure that's pi over 2. Let me just double check. Trace and put pi over 2. And yes, the little blinking dot is right there. So that's at pi over 2, 0. And then the next one would be 3 pi over 2, 0. And then where is it increasing? So that would be from this point until that point. So this is when x is pi over 2, and this is when x is pi. So it would be from pi over 2 to pi. And then it would also be increasing from here to here. So this would be 3 pi over 2 until 2 pi. And then just put a little union, and that's the increasing part. And then for decreasing, so that would be when it goes from here down, so that's 0 until pi over 2. And then this would be when x equals pi until 3 pi over 2. So we've got this is decreasing, got 2 of them decreasing, and 1 increasing, and 1 increasing. Hey, stay awake, calculator. Okay, so that's the first derivative information. And now for the second derivative. And that's what makes this one interesting, because the first derivative is 2 sine times cosine. So we could, in order to take the second derivative, we could do the product rule. But what I notice is that 2 times sine times cosine is the same thing as sine of 2x. Just use that trig identity. Then finding the second derivative is even easier. So the derivative of sine would be cosine. Keep the 2x the same for right now. And then the chain rule means multiply by 2. And there's the second derivative. Now set that one equal to 0. So it really means when does cosine of 2x equal 0? Because of course this 2 does not equal 0. And like I did last time, if you look at the graph of cosine, it looks like this. And so there would be pi over 2 and 3 pi over 2. But then that would mean that 2x is equal to pi over 2, or 2x is equal to 3 pi over 2. And whenever you have a trig equation and it's got a 2 instead of just x, that means you need to look for twice as many answers as usual. So then if you follow this graph out one more cycle, then there would be another answer right here and another answer right here. So if this one's 1 pi over 2 and this one's 3 pi over 2, the next one would be an odd number, so 5 pi over 2, and then 7 pi over 2. So there would also be that 2x equals 5 pi over 2, and 2x is equal to 7 pi over 2. And then all of those need to be divided by 2. So when you divide by 2, this one would become pi over 4, and this would be 3 pi over 4. This one would be 5 pi over 4, and this one is 7 pi over 4. And at this point, I want to look back at the graph and see if that makes sense. So go back to the graph of the original function. And so right about here, it's changing concavity. So this part is concave down, and then from here until here, it's concave up. So this part's concave up. So I can even put my guess that it's going to be changing concavity right there. So that should be pi over 4. So pi divided by 4. Hey, that was a pretty good guess. And how about 3 pi divided by 4? So that should be the next one. That should be right about here. All right, it looks like I've got them right. So then for concavity. So we have, how about starting with concave down, which I prefer to just abbreviate as CD for concave down. So for concave down, that would be this beginning part is concave down. So that's from 0 to pi over 4. And actually this, for the 0, I think I should put a square bracket, because if I widen the screen a little bit and see what's actually happening at 0 itself, this is concave down. So actually this should be a square bracket. There we go. 0 to pi over 4. And then from this, which is 3 pi over 4, until the next one, then this part is also concave down. So that's from this would be 1 pi over 4. This is 3 pi over 4 until 5 pi over 4. So that also is concave down. And I just want to double check 3 pi over 4 from that point until 5 pi over 4. Yes, so from there to there is concave down. And then this will be 7 pi over 4. And so from there until 2 pi, and again, if I widen the screen a little bit, have it go just a little bit farther, then you could see at the end it's also concave down. So right there was when x equals 2 pi, so as it's going through 2 pi, it's also concave down. So from 7 pi over 4 until 2 pi, and then put a square bracket on 2 pi. And for concave up. So that's from this pi over 4 to 3 pi over 4. So from pi over 4 to 3 pi over 4. And then from this one, which would be 5 pi over 4 until 7 pi over 4, so this is concave up. And there we go.